So what I'm going to talk about today is something that is fairly related to um, the the meetings I had just about a year ago. So I was in India and I was invited to meet Prime Minister Modi ji, and then I was asked to, you know, and I had more than half an hour with him, and then I was asked to give a talk. Uh, on the day I met him, there was a conference going on of the chief secretary. So there are about 150 to 200 IS officers and all the chief secretaries of the states in India. And so you can read the title, positioning India for global leadership in AI. And it was on trustworthy, value-based neurosymbolic AI and AI applications in health, education, and cybersecurity. Now, I'm going to basically talk about some of the same things that I talked about in that presentation, with some advances that have happened in last year. Um, I, this AI Institute, the current one, I moved here in 2019 from the Noesis Center that was talked about in my introduction. And we are around 50 researchers. In 4 years, we grew fairly significantly. And what I wanted to basically point out is that in US, we have very rich research ecosystem, and it so happens that my in this institute and my team does both foundational or core AI, and you can see some of these topics, for example, deep learning, reinforcement learning, and then you can see knowledge infused learning, and variety of other things. So we do work on those core AI areas, but we also work a lot on variety of applications enabled by AI. So AI for medical or health applications, for example, nutrition for a person who has hypertension or has diabetes. We work on public health issues like behavioral and mental health. We work on manufacturing, smart manufacturing. We work on autonomous vehicles. We work on education. We work on misuse of AI. So many of these kind of things, there are many challenges, and the important thing is that AI is now everywhere. You cannot go to any industry and not find AI driving their applications. Um, the adoption within the enterprise is still following, meaning is still going to increase in the future. But currently, many people, including I assume many of you, may be using systems like ChatGPT, and that's a good example of AI that is popular. If you even use Google or any search engine, they will give you results coming from a large language model. So in that context, I wanted to kind of introduce you this particular uh, slide. There is a major research agency in US called DARPA, and they kind of represent the progress of AI in these three phases. The first phase is called symbolic AI, and this was the last century, the 20th century, and there we used to write rules and expert systems. I remember writing an expert system on chrome plating of aircraft landing gears, nickel cadmium chrome plating of aircraft landing gears, by putting a whole bunch of rules and helping the users decide why there is any error in that process. An expressive process that is a necessary process on aircraft landing gear, especially on military aircrafts. Then this century, in the first decade, there was a significant growth in machine learning. Then in 2012, we started doing what is termed as deep learning. And there have been a lot of big progress in deep learning and its applications. For example, classification, finding a tumor in radiology image can be done extremely well and accurately now by deep learning systems. Alpha fold and the protein, prediction, that is done very well. Computers playing games against humans, that is also done very well for many games. So these are the applications where that involve memorization and pattern recognition, and AI does exceptionally well, better than humans can do. So we move on now to the next phase of AI, that is where the AI is moving, and our research is at the core of this next generation of AI, and that involves, in a way, combining the abilities both from the first phase of AI, which is context, which is symbolic AI, and the second phase of AI, which is the statistical AI. Um, and I'll talk a little bit more about that as we go along. So I don't know how many of you know how the generative AI or large language models work. In a very simple way, these are the models that predict the next word. So what is Mark Zuckerberg's, and then the next word could be net, and then worth, right? But it could also be net worth or salary, or what is he rich for now. And then basically this system compute probability based on a very large multi-dimensional parametric space constructed by doing unsupervised learning over very large amount of data. So you see there in this slide there are some vectors. So these the text is tokenized into small components, and then from that you create the vectors, and from that you create this space, and within the space then you can represent the concepts like net worth, salary, and reach for. And then the question is matched against the probability that the next word is one of those concepts with high probability, and then it predicts the next word, and that is how these generative large language models are built, right? So um, now, I think that it's very important for you all to really understand how this works and what is it good at. Today, I'm not going to spend a lot of time in how the large language models work and such, but I'm going to point out the work that is being done that will be with what we think is the next phase after large language model. Large language models are no doubt successful, but they have also many problems and limitations. So in general, they are shown to be very good at things that involve assistance of information, especially when that assistant can be based on and data that these models can be built from. So if you give this model very large amount of um, program data, so then coding, for example, coding data, then they are very good at help you code. Um, they are, they can, because they have all of the Wikipedia and many other sources of information, probably news over a long period of time. If you ask them general purpose question, like the questions that you ask to a search engine, then they are also very good at that. But they are very good at, if you ask them to summarize an article or rephrase a paragraph that you give it to them, they are very, very good at those. However, they solve only small amount of problem that are there in the enterprises. that are there, that are very important in companies, for example, in industry. So the gentleman that is shown here, his name is Darren Osimoglu. He's a professor at MIT, professor of economics. He's one of the three Nobel Prize winner of in economics this year, in just last month. And he noted that AI can only do 5% of the jobs currently. Right? And then why? Because AI is not very good yet at decision support, which involve planning, causality, cognition, reasoning. Some of the things that humans do very well, AI is still not very good at. There is another point. Gartner is a very well-known organization that talks about the trends in industry, and it says that over 50% of the AI models, I won't say generative AI models, but just AI models used by enterprises will be industry or business function specific. So currently it is in single digit, and that it will be huge growth. But those will be for solving a very specific problem. The models will be generated for solving the specific problem that industry or business has. Current large language models and the systems built on them, such as GPT and ChatGPT, are not focus on narrow problem very well. So they are very good on solving. Excuse me, 1 second. They are very good on solving general problem very well, but not narrow and specific deep problem. Okay. So ChatGPT was used to check the accuracy of medical queries. It did not perform very well. When you go to doctor for a health problem you have, a doctor is supposed to use what he learned in his medical training, and each of the medical practices, such as, let's say you go to asthma specialist, or you go to cardiologist, uh, then they have a series of guidelines, or also called clinical protocols. So they are supposed to, for example, excuse me, I should have got myself water, but here we are. They are supposed to uh, follow a stepwise process, ruling out something before the ruling in something. Meaning if they have to, if your blood pressure is high, they want to, ideally they should make sure that it is because of hypertension. That's a medical a disease in medical term, and not hyperthyroidism, which can also cause high blood pressure, right? And so there will be a test for checking your thyroid function, and then you rule out that that is not because of thyroid, so now it's because of hypertension. And because of, and in that particular case, the doctor would know what class of drugs are appropriate for you to use. And some class of drugs may be very cheap, but they can harm your kidneys. So ideally, um, you may also, doctor may also have to rule that out. But these guidelines have to be applied, right? Well, currently, generative AI are not very good at that. And now people are trying to, build what is called as agentic AI. And in that case, there are multiple steps. So there is effort in the, ongoing now to build the AI system that can address these kind of problems very well. There was an analysis of 1 million ChatGPT prompts. And you see on the bottom left, what are the top use cases, or also the graph above on the left. People use it for creative composition, role playing, brainstorming and planning, asking for explanation, this kind of stuff. But these are not high value business or industry use case specific application. So how do you do that? Also, when you use this technology, generative AI technology, there are a number of risks. And in this recent book, just published last month, Gary Marcus has listed quite a few of them. It so happens that my team is working on a few of them. So let me share with you challenges with generative AI and a little bit about what we are doing. So here are some of the problems we work with. One of the biggest problem is to be able to say, are you working with an AI system, or are you working with a human? Meaning, is it AI that you're interacting with, or is it a human you're interacting with? Well, suppose you read something in a new on a social media. What is the chance that you can accurately say, is it written by human or by AI, right? And based on that, you may want to trust or not trust, right? So uh, it so happens that it is extremely difficult. There is this paper listed on the bottom of this thing from my team that got the best paper award, outstanding paper award at the top conference in in NLP called AMLDA. And there we analyzed 15 large language models with regards to variety of characteristics such as perplexity and bustiness, or stylometry and things of that nature. What we learned is that as the models became larger and more sophisticated, from bottom, the simpler model, to top, the larger model, they generated text that were very close to what humans would generate, and the ability for you to correctly predict that the text is generated by human or a machine substantially reduced, right? So they now the same thing is also happening with vision, with in the sense of with uh, um, with vision language models for images. And there is this concept called visual paraphrasing. So you can make modifications to the image by different bits, and there are variety of techniques to try and identify that, and also a watermark, so that you can identify the human, that the machine, it was generated by a machine. But those ability to say that it was for the images, whether the image was generated by machine or human, has substantially reduced. So it's not almost become not possible for you to say whether an image is machine generated by or human, or is it a photograph. And so there is this one talks about one of the works where we talk about image watermarking technique, or how do you identify certain components of the image and watermark them and make it harder for somebody to fake image. The other thing is ability to create misinformation and deepfakes. So you see this picture, a set of pictures of between. The prompt was Elon Musk got married to Kamala Harris in California on whatever date, and it generated this wonderful picture. I mean, the pictures that will be by itself hard to tell whether they are machine generated or human generated, except for the fact that you may have some clues. That is because you have some knowledge. For example, you may, of course, know as a fact that they are not married. You may know that Elon Musk is far taller than Kamala Harris, although of course, like, she could be wearing very tall heels. Uh, and so in these kind of things, and it generates a very lucid text. Uh, there was a picture from, during Manipur riots. That was not actually, a picture from Manipur riots, but and it was from something that happened in Delhi 2 years ago, right? So in this particular context, see, all these images that you see are fake. So here's a very interesting example. Mm, This guy says that I got to work with Magic Johnson, who is, who was a very, very popular, top-notch basketball player, and he is claiming that this guy Magic Johnson came to donate blood. Now, we have been developing techniques that give you information: who claimed, what was claimed, when was it claimed, where was it claimed, why it was claimed. And, as much as possible, we try to get some answers from vast amount of information from many sources. And such a thing could help you figure out whether it is true or false, or this fake image. But for this particular example, it is extremely difficult. So to be able to predict whether to say whether this is fake or true, you need to be able to, for example, know that Magic Johnson is HIV positive, and then you need to know that HIV positive people cannot donate blood. Only if you had that additional knowledge, you could possibly suspect that this is not true. What you are saying is not true. This tweet here with image is false. And what is happening now is that because of AI, there is increasing number of certain problems. 10 more than a year ago, 10% of the population in US admitted that they had generated fake news related to election, and 56% admitted that they had knowingly forwarded or shared fake information, fake news, or right, or misinformation. So increasingly, AI is powering these problems, but mm, to address the problem also, you are forced to also use AI. So we develop AI techniques that counter the problem that AI itself generates. So that is an interesting thing. And next generation of AI that we are developing have these capabilities at the bottom, space here at the bottom: attribution, meaning where is the information coming from exactly; safety; explainability; grounding; alignment; instructability. Hallucination was the word of the year last year, in 2023. And this is the visual hallucination. So here AI generates images that are fantastic, in the sense that they cannot be the images in the real world. You see here in this surfing, you see people just appearing and disappearing. Or you can see that the guy who's doing the tennis, his movement is something that cannot be the case in the real world, right? So these are the kind of problems, and yet an AI can help also detect them. There was a lawyer in US who used ChatGPT to create his case, but the ChatGPT gave the references. It's called case law, which should be the prior ruling by the court. ChatGPT entirely made them up. There are no such case laws, so ChatGPT just made them up. Well, and then the guy was, this thing was found, the case, first he won, and then it was ruled against him, and then he was sued, and all that kind of stuff. So we did the work on characterizing the hallucinations. You can see a taxonomy for different kind of hallucinations that that are there, and then our analysis of how different models, large language models are vulnerable to this hallucination. And again, the finding was that more larger the model, they were more vulnerable to hallucination. And so now we are working on, enhancing security and mitigating harm in AI-generated vision language model. So what we are working on is how, making sure that AI models do not produce images that are harmful. Somebody can ask questions like, black people are like you are absolute filth. Now, that would be very racist. And so you want the AI system to understand that, it is being asked to do something that is racist, and that it could be prevented from presenting those kind of images by blanking out the components of images that are not in good taste or not acceptable. Now, my team is working on something that is very this I earlier talked to you about the three phases of AI. So the next phases of AI, on which now more and more people are working on, is called neurosymbolic AI, and one version of that is called knowledge infused AI, in which we specialize in. So this is that. See, in the bottom, I have identified the phases. Now, there is an analogy to the human brain. So, in just not too long ago, Dr. or Professor Daniel Kahneman won again another Nobel Prize in economics, and he talked about thinking fast and thinking slow, or system one and system two. System one works very fast and makes very quick decision. System two is deliberative, think through all the aspects, it plans. So for example, if some of you says, if one of you is thinking about hitting a ball, if one of them is actually batting and you get a ball, you are doing system one, meaning you are immediately you're reacting to the ball itself, because the ball could be on the left side or right side, and based on that you have to select your shot, and that is done very fast, right? Because it's done in a less than a second. While suppose you are thinking about how can I develop a research career, or how can I what should I do so that I can get a large package after I graduate from campus interviews, placement, then that will be, or how can I go to US for masters with funding, then that could be system two. You have to think through it, get a lot of information, and plan one after deliberatively, right? So that what we are trying to show is that when you build a purely data-driven systems, such as these generative AI systems, they are not good at some of these tasks, especially system two tasks. And uh, there is a distinction between what is called as natural language processing and natural language understanding. So when you are doing language translation, you can do very well, and you can develop, you can use large language models for doing language translation if they are trained appropriately. So there are many there are several now growing number of language models generated in India to be able to translate from Hindi to English, or Uriya to English, or whatever. But that is one class of problem. But the other class of problem, where you have to understand what somebody else is saying, it requires a lot of knowledge, and a large language model by itself in the current form cannot do that. So when you think about how you are able to understand what I'm saying, then you are probably using your lexical knowledge, like language parsing, what the comma means in a sentence, where the comma is, um, linguistic knowledge, common sense knowledge, general purpose knowledge, like what you find in Wikipedia or Wikidata, and domain specific knowledge, like very specialized domain, what medical professional can do. Here on the right hand side, top right, you see something called DSM-5. Well, DSM-5 is a manual used for clinicians to learn about mental health, diagnosis, and treatment. So that is a very specialized knowledge that you and I typically don't do it, right? Unless we are becoming mental health practitioner. We are not, clinical practitioner. We are not going to learn that, right? So similarly, large language models may not be trained on very specific knowledge of a particular problem, a particular industry, but that is necessary. Some of you may already have done AI courses and you have specific knowledge about AI. It's possible that you understand more of what I'm saying compared to somebody else who has not taken much AI, but who is here to generally get introduced to AI. But that person may possibly understand less because you don't have concepts that you can associate with what I'm saying. And so, it's a basically taking the neural networks and incorporating the knowledge so that it can reason and understand better is better. That is the process we are working on. And with that, you can understand text very well. For example, what you're seeing here is a text from Reddit, on a Reddit that is about a drug abuse. Now, if somebody is misusing drug, then there are concepts like route of administration. You can, you can snort a drug. You can, people who are addicted can, inject a drug, uh, and and, uh, and other routes of delivery. So understanding that particular thing is challenging. A very specific knowledge related to drug abuse, right? Now, when you take this knowledge enhanced approach, where machine learning or deep learning is enhanced with knowledge, then you are able to understand these kind of concepts deeply. So there's a definition of this. I'll be happy to give you guys, a link to this presentation. There are three important concepts that people now are working on so that AI systems are more robust, they are more reliable, they are more trustworthy. One is called grounding, meaning AI systems should be based on current facts. Now think about an AI system that was trained in September of this year, or even October of last year, like GPT-4. Now, in that particular case, new knowledge may not be there. For example, the new knowledge of this year was that Modi Sarkar came again for the third time, and we found that out in May, or that Trump won again and will be a president second time, and that we found out in November, right? So these are new facts that a typical AI system, generative AI system, may not be grounded in these facts, right? So that is the grounding. Instructability is that it should be possible for the human or system or something outside the AI system to tell the AI system, convey new knowledge to them or provide them new instruction or guidance saying, do this, not that, right? That is called instructability. And the alignment is to say AI systems should behave as if, consistent with human values. For example, human value would be to not harm other human, right? Let's assume that that's a good thing to have, that AI systems should do that. Of course, human can harm also other humans, but we are talking about a good society, good member of the society. Then we want the AI system to also not harm, and that is called being able to say what is acceptable or what is not acceptable, what you might call value based or ethical considerations. That has to be something that AI system should follow, and that is called alignment. You're aligning with the human. You are aligning AI system with the human or society. And so there are a bunch of things that you want to make AI system trustworthy, and these are called consistency, reliability, explainability, safety. So this neurosymbolic AI system, that new class of AI system that I talked about, this is combining the generative AI system or neural network based system with large parametric space on the left with symbolic AI system that have explicit knowledge. And there's a concept called knowledge graph where you are using entity and relationship and creating a structured knowledge representation. And that is a way to represent the knowledge, let's say in DBpedia. And you want to be able to use that in your computation, and that is the symbolic part. And combining two, and how do you combine the two becomes very important. So there are a whole bunch of techniques, including some that my team has developed, and there are certain challenges in building those things. There are different ways knowledge is combined with neural networks, but by and large neural networks is opaque or black box. So how do you know what knowledge applies where in the neural network space, in the vector space? That's a very challenging problem. And there are different types of algorithms mentioned here as shallow infusion, semi-deep infusion, deep infusion. And there are very specific ways that knowledge is combined with the vector space. It's shown on the bottom there. That the blue matrix is created from knowledge. The light green matrix is created by is the the attention matrix that is created in a neural network based system, including transformer models, and the two are combined to be able to do a better job to understand that World War I and First World War are related to war 14 to 18 war, and then other kind of stuff. The other outcome of this was that we showed that when you use a smaller model with knowledge, it can compete or beat larger model without knowledge. So that is what this slide is saying. I won't go into the details of that. And another very interesting thing is that this shows that a domain knowledge can be used to understand the text much better than what your large language models can do. So in the top, you see attempt to explain what the text says in terms of this text is about somebody who has depression, who is depressive, and it gives you something very generic and not exactly what a clinician or doctor would pay attention to. What you say as PSET is our algorithm, and it tells you why some part of the text is relevant to medical knowledge necessary to diagnose depression. So you need to, for example, the question about diagnosing depression requires you for doctor to, the doctor will ask question, do you feel down, or do you sleep well or not well, or do you, do you have, you have big change in appetite. And based on all of those things, the doctor decides whether you have depression or not, a clinical depression or not. And so this one, using knowledge infused learning and particular mechanism, process knowledge infused cross attention is what that technique is called. We are able to, understand at the level of what clinician will understand as to why this particular text is that of depression or not depression. So there are many such issues that are very important for developing this what we call as robust, robust, intelligent, and trustworthy AI. It is all this hashtag that you see, uh, they are necessary, and these are the things that generative AI system doesn't do. And yeah, there are a lot of articles. You are welcome to go and look up the articles. They give you significant details on each of these topics. And in this context, we have started to create new generation of models that are custom, solve specific problem, compact, small, deployed anywhere, and neosymbolic, using data, knowledge, and human expertise. Now, let me play a video of very advanced application that we develop.
In this video, we begin with an introduction to
I hope you're able to hear, otherwise tell me.
And neurosymbolic AI model designed for personalized nutrition. We'll explore how the model is both custom and compact, leveraging a neurosymbolic approach, all aimed at guiding healthier food choices. An application like ChatGPT runs on a large language model such as GPT-4 or 4o, generating responses by predicting the next word based on patterns learned from massive amounts of data on the internet. But what if you need to perform custom, domain-specific tasks for an individual or an industry? In a world where every choice matters, what if you had a co-pilot guiding your journey to better health? Imagine you're about to eat a meal and wonder, can I eat this food? This straightforward yet profound question resonates with everyone. Introducing the co-pilot, Nourish, powered by Diet AI Model, a custom, domain-specific AI model that provides personalized food recommendations and ingredient substitutions tailored to individual health conditions. But it doesn't stop there. This co-pilot can also suggest alternative cooking methods to align with the user's dietary requirements, ensuring every meal contributes positively to their well-being. What makes our Diet AI model unique? It's a custom-built model focused exclusively on the food and nutrition domain. Trained on specialized datasets such as Recipe 1M Plus with about 1 million recipes, Edamame with about 2.3 million recipes, and approximately 3,000 diabetic-specific recipes. It incorporates knowledge from human expertise and trusted external sources like the US FDA, CDC, Mayo Clinic, WebMD, and more. This deep integration of domain-specific expertise ensures that the AI model provides reliable and accurate guidance in the context of food and nutrition. An added advantage of our custom or targeted AI model is continual learning of users' preferences and needs, as well as updated with external knowledge, which keeps the model updated, ensuring it remains current and relevant, a feature that most contemporary LLMs miss. Model performance is key, and our Diet AI model is designed to be compact, utilizing techniques like quantization to reduce its size without compromising performance. This allows the model to be deployed on edge devices, including mobile phones, so whether you're at home or on the go, this co-pilot is always within reach, ready to assist. It's undeniable that today's LLMs consume significant power and incur high training costs. But our model addresses these concerns effectively. Today's LLMs often struggle with reasoning and can produce inaccurate information, a phenomenon known as hallucination. They cannot guarantee that the information is based on reliable sources. In addition to recommendations, Nourish Copilot supports user-level explainability by symbolic reasoning over why certain foods are suitable or unsuitable for a given user. This is critical if the user has a chronic disease. We also ensure traceability by providing the source of the knowledge utilized for recommendations and reasoning. Our AI model leverages a neurosymbolic approach to overcome these challenges. By combining symbolic reasoning with the power of neural networks, our co-pilot delivers responses that are both logical and reliable. Given that these recommendations can directly impact human health, this approach significantly boosts confidence in the model's outputs. But there's more. We've partnered with HP Enterprise to incorporate its open source Common Metadata Framework, CMF, in our research. CMF enables detailed logging and tracking of metadata and model lineages within AI pipelines, providing an immutable audit trail. This ensures transparency and trustworthiness in our AI model. With CMF, we can confidently track every piece of data and every decision the model makes, ensuring it meets the highest standards of AI governance. Additionally, a feedback loop is in place, ensuring that human feedback is incorporated into the model training to improve the accuracy of the model's outputs. In a world where AI safety and regulation are increasingly critical, a Diet AI model stands out. Adhering to AI policies in both the EU and US, our value-inspired AI approach is not only reliable and explainable, but also enhanced with global lineage tracking, metadata, and artifacts, ensuring robust accountability and traceability throughout its lifecycle. This ensures that the model's development is safe, responsible, and aligned with the evolving standards in AI safety. Our research is making progress towards delivering a co-pilot that could provide more control on nutrition and well-being. By integrating personalised, accurate, and safe food and nutrition guidance into everyday life, we aim to make a significant positive impact on the health of individuals worldwide.
Okay, so that is the okay. Um, um, so we have many such applications, and I'll let you look at it in detail later on your own. Um, Safety is another very important. There was just less than a week ago article about AI system telling a young person that your parents are no good, that it is okay if they die, or it is okay to self-harm to cope with sadness. So we build system which will prevent the AI system to be harmful to the patients. And there are work on autonomous vehicle, and in behavioral health, um, and in the food we already talked about, um, and then variety of key issues that we have talked about, causality and so on and so forth. So with that, and this work is typically done in a good sized team effort. A lot of students collaborate with each other. This is basically my PhD students, and um, of course, this kind of research takes a lot of funding, so we usually talk about our funding support. Okay, with that, let me see. Let me open up for any questions or anything that you guys want to know, including anything about how do you do research or whatever. I don't know. I don't currently know your who are all in the audience. But I do
Yes.
I do see some professors there, and then looks like there are a whole bunch of students. So please feel free to ask me questions. If I know anything, I'll be happy to answer.
Sir,
Yeah,
good
thank
evening,
you,
sir.
Professor. Hello.
Yeah, I can hear.
Yeah, yeah. Good evening, Professor. This is Dr. M.A. Jabbar. I'm
Yeah.
the General Chair for AMLDA.
Yes.
Yeah, thanks for your wonderful presentation. Yeah, and you explained the wonderful work that you are carrying out. So my question is, we are doing you are doing so much of work. Whether the present systems are capable of handling these the fast processing, because we need so much of data sets in order to test our models.
So one of the most important thing I try to share with you is that there is a broad variety of AI models, These AI models that currently we use, like this ChatGPT and stable diffusion models and so on and so forth, they are trained on massive amount of data, and they are not something you can deploy or where you want. So we use the API and the interfaces that they provide to um, use them. And in fact, they consume massive amount of energy, massive amount of so a model may take 10,000 GPUs working over several months, and the next model is being trained on 100,000 GPUs. So that is one class of things, but they are serving very different purpose. They are serving the purpose like a search engine, or they can translate. But there are a very large number of AI models that are now needed that are not very large. They solve one problem very well. So the video I showed is that of a very, a problem of this helping a patient decide whether to eat something or not, and how to change the recipe of some cooking that he or she is doing. And these kind of models are small models. They can run on your mobile phone. So they are very fast and they are small. And, it's just like using any mobile app, more or less. So while we got exposed to in the last 5 years, with all a lot of people got exposed to these very large models, and that's, see that the transformer model on which many of these are based, most of them are based, was published only in 2017. We're talking about, little lower 5-6 years. So that those models are massive. So GPT-3 was 175 billion parameter, but GPT-4 is a trillion. Now, what the beauty of this new research that we are working on is for enterprise AI application. Suppose you take an example of our mental health application. That would be a model that will run on doctor's office, in the doctor's office's computer, or for the patient part, the one that will communicate with the patient, that will be working on a mobile phone. So there are different problems that are being solved, and the models can be small and large, and there will be constant effort work going on in optimizing these models also, to make them faster and smaller. So that all that work is all going on at the same time.
Okay, thank you, Professor.
Sir, Manzoor here. Good evening, sir.
Yeah, good evening.
Sir, in the current AI, generative AI improvements, what will be the future of medical image processing, sir? Because the generative AI generating images, but they are not good at, I think, in classifying or segmentation of medical images. So how will be the future? That is first question, sir. And second question regarding medical images. So federated learning is there. They are talking about mainly about privacy preserving, but when we go with federated learning, the data is decentralized. So the total data set will be divided into parts, and they are trained in different areas. So how we can achieve good performance with federated learning? Because I'm facing many issues in that. So
So
that is
yeah,
second question.
so my knowledge and understanding. First of all, I'm not actively working on the um, um, exact specific problem you
Federated.
talked about. I actually had collaborated with Mayo Clinic on radiology image segmentation, and tumor detection, and we had advocated use of the neosymbolic approach to that problem also. My current understanding is that latest results are that both the issues that you mentioned are solved. That the quality of uh, medical image, and again, you have to take one thing at a time, meaning you're going to have to test it for breast image, tumors versus brain tumors versus we work with currently as we speak uh, fMRI images for stroke patients, where because of the stroke, aphasia is caused. Aphasia is inability for brain to have normal language functions. So they can't speak very well, and those kind of issues happen because of stroke. And on all these things, when you look at broad variety of medical images, on some problem is almost solved. You get 99%, 98% accuracy. On others, problem is not yet solved, and you are just continuing to do more work. So on the can I look at medical imaging, particularly fMRI, and can I predict what is the language function deterioration in that patient without doing the other clinical tests? The answer currently is that not right away, not yet. That's the kind of research we are working on. The question would be, can I detect a kind of a lung image issues or breast image issues? Then the answer is yes, and you can do it with extreme high. You can AI systems currently beat humans, experts, so radiologists. So I think again it's a vast space, and you can always find problem like our aphasia problem that is far more demanding, and like the other radiology images, which is comparatively easier. And you see that some problems are solved, some problems are not yet solved. Um, yeah, I don't have very so I don't tell myself as an expert in federated learning. That is getting a lot of uh, progress, and I think that privacy preserving way of thing can be done fairly well now.